All right, so for your chapter 20 problem set, question number 1 is explain how voltage gated channels open across the membrane at a certain threshold voltage. Well, the way this works is basically these voltage gated channels have positively charged residues within the membrane. All right, in the case of the potassium channel we talked about, it was a charged helix. In this case, a positively charged helix that sits within the cell membrane. Now, that charge basically, because there's a charge difference across the cell membrane, it's going to tend to be attracted towards the negatively charged side of the cell membrane. Now, when there's a change in the voltage that occurs across the cell membrane, there's going to be a change in how strongly that helix is attracted to one side of the membrane versus the other. All right, and so that helix can basically move either up or down within the membrane. And it's this movement of those charges within the membrane that then causes a conformational change that opens up the pore of the protein. All right, so that's basically number 1. So it's the movement basically of charged amino acids from one side of the membrane to the other that are causing conformational changes that then open up the pore of these voltage gated channels. Now, question number 2 is a bit more complex, and so this one I'm going to make sure to go through with you guys and write out the whole calculation here. So it says to calculate the chemical potential for sodium across the membrane given the following information. Now, so what is chemical potential and what's the formula for chemical potential, first of all? All right, so the chemical, or the formula you're going to want to use is this delta G bar of chemical A. So A in this case here, this is the chemical that we're interested in. All right, A is sodium in this case because I'm asking about the chemical potential for sodium across the membrane. So delta GA is going to be equal to RT times the natural log of the concentration of A on the inside versus the concentration of A on the outside. All right, now again, A here, this is the concentration of sodium in this case. All right, plus now Z, which is our charge of Z sub A, that's the charge of A. So a charge of sodium times Faraday's constant times delta psi. All right, so now let's think about the things we have here. So for sodium, we've got its concentration both inside and outside the cell, all right, which are these components right here. We know the gas constant, we know temperature, which I actually forgot to provide you in the problem. I'm not going to be too picky here. I'm going to choose 25 degrees Celsius or 298 K. All right, the charge of sodium is +1. All right, Faraday's constant, 96485. All right, so we basically have almost everything here except for one component, this delta psi. All right, so in order to calculate delta psi, we're going to have to use a second formula to do this. All right, now, oops.